This is video 45 on MicroPython and LVGL 9.3 on a standard ESP32 board. In a previous video, we discussed LVGL Flex. Now we discuss the LVGL Grid layout feature. The LVGL Grid does the work of positioning widgets. Since LVGL Grid configuration is a bit non-intuitive, we will utilize both hardware and the online simulator to help us understand it. Please let us know in the comments if you like this example, or let us know if you have suggestions to improve it. For this effort, our test rig is based on the ESP32-S3-DevKitC-1 USB board connected to an ILI 9341 display. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal for this effort is to start to use the LVGL Grid. We will demonstrate a test program that utilizes an LVGL Grid. We will discuss the LVGL Grid feature as presented in the online documentation. We'll present a test rig, wiring, and firmware. We'll demonstrate the grid examples which we migrated from the user doc, and we will review one of the code examples. The program files are at the GitHub site that is mentioned in the description and endnotes for this video. Let's open test grid data _ display. As you can see, the program is already running. The screen consists of 3 buttons and 2 LVGL objects that are child widgets of a container widget that's in a grid layout. Pressing the button labeled sample generates a random temperature that is displayed in the left object, and its average is displayed in the right-hand object. We'll press it several times to increase the count. Pressing the middle button labeled list causes the program to display the values. It will display up to 10 values. Thereafter, it displays the last 10 values. Pressing the last button, labeled Clear, causes the program to clear the internal array and load the initial temperature value. That's it. The program was inspired by the Example 2 demo program. As the 2 demo examples are just static boxes, I thought this demonstration would help understanding. The next 4 slides provide a basic discussion of the setup for an LVGL grid. A grid is a layout function that uses a container widget to arrange child widgets into a 2D table of columns and rows. By the way, columns and rows may also be verbalized as tracks. As an example, the picture shows that we defined a button in column track 1, row track 2. An important aspect is that a child widget can span multiple columns or rows. In the picture, we can see button 1 is in row track 0 and spans columns 1 and 2. Let's discuss the grid container. The container widget uses the setGridDescriptionArray function to specify the grid. We provide it with a column description array and a row description array. A description consists of an array of integer pixel sizes for each column or row. The last value in the array must be a constant LVGridTempLast. The container widget must be defined as an LVLayoutGrid using the setLayout function. The child widgets are defined using the setGridCell function. The first 3 parameters specify the columns, and the last 3 the row for this grid item. Notice the first parameter is a grid align constant like start or stretch. Finally, we can optionally use the setSize function to define the item's width and height. Instead of a numeric value, width and height are usually specified with LV size content. By the way, LV size constant is used in the LVGL demo code. We believe the constant instructs LVGL to set the size of the grid cell to fit the child widget. Now that we presented the LVGL grid configuration, we can test the functions in the online simulator, which we will do in a few minutes. First, let's discuss the test rig. Let's look at the test rig wiring. We need to wire the ILI9341 display and touch features. The module on the ESP32-S3-DevKitC-1 has 2 SPI ports and allows us to use any pin for the control lines. We earmarked the second SPI port for the SD card, which is not used in this example. Fortunately, the display and touch features can share an SPI port. This slide depicts the wiring between the ILI9341 and the ESP32 module. It shows the pins of the header on the back of the display. The touch pins for the SPI port are wired in the breadboard to the SPI pins for the display. For simplicity, we utilize just the pins on one side of the module. The firmware called ESP32-S3-Octo in the May 2025 directory at the GitHub site is still recent, having MicroPython 1.24.1 and LVGL 9.3. It was fetched 2 weeks before the formal 9.3 release. We can continue to use the same driver files. These files must be copied to the flash directory of the ESP32 module. This can be done easily with Thony or using the MicroPython MP remote command line tool. Now, let's get back to a demonstration of the LVGL grid functions. The picture shows 2 grid example demo programs at the online doc website. We migrated both examples to MicroPython. Now we have the online simulator running. Let's replace its example code with the code for the example one from the online doc, the one that I've migrated. First, we'll remove and now we'll paste in our code. Now, when we do this, we need to remember to remove from machine import reset in these lines because they're already in the simulator. Now we can restart the program. When we do, you see in the display the screen that's very similar to the online documentation for the first example. All right, let's run the second demo. We're back to our default. Let's remove the example code. Now we'll go grab demo_grid2_display and paste it into the simulator. All right, and as before, we need to remove these 3 lines because they're already in the simulator. All right, let's restart the program. All right, the second example in the online doc on grid and the display that we're seeing in the simulator looks very similar to the example 2 in the online doc. This example is a little bit more interesting and helps us understand the grid function better. So let's walk through the code. All right, the first thing we need to do is define the container. And that's these lines right here that start with CONT. As we mentioned in our presentation, we need to define a column description and array and a row description array. And here I've picked the column widths for the column as 70 pixels. So I have 3 columns that are 70, and then I have that constant. And I picked the row description height to be 50 pixels. And now we load that into the set grid description array. We're going to set the overall size of the container to 300 by 200, so you can see it's about 300 pixels wide and 220 pixels high. I've set the background black so that it's a little bit more vibrant to see the objects. So that's one difference from the online doc. And we end the container definition by using the set layout. And so now our LVGL program knows which object is the object with the grid, and that's the CONT object. All right, so now we can define each of the objects. And I'll begin with the 3 objects at the top, which are C0, R0 is the first one. So that's this object. Notice that we're defining an object which becomes a rectangle on the screen, but it's a child of container. Now we set the size of this object to be using the constants size underscore content. And as we mentioned earlier, the most important one is this grid cell. So as we remember, it's defined in groups of 3. There's a constant, and then which, in this case, since we're defining the column, which column it starts in, and then the span. So if you recall from our pictures, this is column 0, this is column 1, this is column 2. So this particular object is defined to start in column 0 and be one column span. And it starts in row 0 with a span of 1. Now we insert a label into the object, and we give it some text so we can identify that particular rectangle on our screen. In a very similar manner, we do the next 2 objects. Notice that the center object begins in column 1 for a span of 1 in width, and it begins in row 0 for a span of 1. And the same for the third and last button. It is defined to be in column 2 for a span of 1. It starts at 0 for a span of 1. So all right, finally we come to the last 2 objects. Now, I've written the program the same way that it was written in the example, but it's going to be easier to understand things if we take this object and just move it. Because now this object describes this first rectangle, and we can see that it's defined with these grid-aligned stretch constants. And we'll come back to that stretch in a minute. But what is it defined as? So it's defined to begin in column 0 for a span of 1. So it's very similar to the one above. But if we look at the row definition, it starts in column 1, which makes sense, but it's 2 spans long in height. So hence we get this shape. If we look at the next one, the last object, it begins in column 1, which makes sense. It has a span of 2 column and it begins in row 1 for a span of 1. So it has this shape. All right, so I like the fact that these last two objects give us some idea of what's going on here in terms of this grid cell definition. But what is this stretch? Well, let's take a look at it. Let's use the Repo to figure out what these constants are. So we can do that by creating an arbitrary value, which we'll call A. So I've created a variable called A that's LV.grid align. Now we know in the REPL that we can have it finish what the definitions are. So if we type A, which represents the LV grid align, and then a dot, we can now press tab and see all the constant values. So you can see there's a lot of them. There's space evenly, stretch, space around, and space between center and start. Okay, so why did they use this stretch? Well, let's go in and replace stretch in this first object to start. And we'll change the row definition as well. Now I'm going to restart the program. Now when we do, even though we told it to span 2 rows, it's kind of small compared to what we expected. So in other words, the stretch is actually going to make it stretch to the full size of this span. Right now, it's kind of pushed up into the start or the top of the area that we described. So now let's replace it with end. Okay, I replaced both with end. Now, this area of two rows span, the object is pushed to the end or the bottom of the span. So that's what start and end do. It aligns it to the top or the start of the span area or to the end. If we do stretch, it's going to stretch it across the whole area. Let's put it back. Right? We can do the same thing with the second object. We can change it to start. And now we'll restart. And as you can see, the object is pushed up to the beginning of that 2-column span. If we change it to end, it's going to move this object to the end of the 2-column span. So what I found is the simulator is a good way to take your program and check out the shape that you are really looking for in your program. And so when I was developing the grid data program that we showed at the top of the video, I used the simulator to test it out. Let's in fact do that. So now I've grabbed I've grabbed the grid data program. I'm just going to replace the code that was there, make sure that I've taken out the from machine import reset. And by the way, why am I making sure to remove that line? What this does is it provides a way to reset our microcontroller, but I'm sure the maintainers of this online simulator site would not appreciate us restarting their computer. So so they make this an illegal command. And we'll just remove it. But we'll keep the import for the random and restart the program. Okay, now you see the same program that I showed on the ESP32 is in the simulator, and I can press the buttons here, and it works exactly like we saw on the microcontroller. Hopefully seeing this example helps you better understand how to define a grid container and its child widgets. In summary, in this video we demonstrated a test program that utilizes an LVGL grid. We discussed the LVGL grid feature as presented in the online documentation. We presented the test rig wiring and firmware. We demonstrated the grid examples from the user doc in the online simulator, and we reviewed an example code. The benefit to us using the grid object is simple and more flexible code. Please comment if you feel other changes are needed in this example. I hope this video helps your LVGL MicroPython coding. Thank you for listening.